In this video, we are going to go over literal equations. And all a literal equation is an equation with multiple letters, multiple variables, in which you're solving for a variable. Okay, so what happens is in math is that some equations have more than one variable, as you can see from all of these examples. And sometimes the one that the equation is equal to is not the one you need. So you need to be able to move variables around and get the one that you need. And with that, you're basically going to do the exact same thing that you would do for any normal equation. You're just solving for a particular variable. So in this first case, all right, we are solving for a. This tells you what you're solving for. So that means we got to make sure that a is by itself on one side of the equal sign. All right, so what that means is we have to move everything else away from a. So I'm just going to go down my list here. So I have an m on this side, a negative m. So to get rid of it, I'm going to add m to both sides. It goes away over here. And I now have z plus m on that side. And I'm going to keep going. So I have a b on this side, so I'm going to subtract b from both sides. This goes away, and I now have z plus m minus b is equal to a. All right, and this is your answer. We solved for a. A is now by itself on one side of the equal sign. And that's all there is to it. I mean, there's different situations, and we're going to go over those different situations, but the fundamental principle, what you're trying to get to, is whatever variable that you're solving for, you want that variable on one side of the equal sign. So let's go to this next one, number 2. Again, we're solving for a. Here it is. So in this problem, we have a times m. The only way you undo multiplication is by dividing. So I'm going to divide m from both sides. And now I have a is equal to n minus p divided by m. Okay? And this is something I want you to pay attention to, is that we divided m by the whole side. All right? So make sure in your answer you have m is divided by the whole side. You don't just put m under one of the letters. It's divided by the whole thing. Now, in this problem, we do notice, though, that we have a variable in our denominator. Okay? Brief reminder on division, anything that is divided by 0 doesn't work because the answer to this is undefined. Oops, that's not how you spell that word. There you go, undefined. So whatever you do, whenever you have a variable in the denominator, you cannot have that variable be 0. So in addition to your answer, you also need to put that m cannot be 0 to make sure that the fraction still works. So this whole thing would be your answer, minus my arrow. All right. So whenever you have a variable in the denominator, you have to set up the situation that the variable does not equal 0. Or, well, the denominator can't equal 0. In this case, our variable is the only thing down there. But the thing you got to be aware of is the denominator cannot be 0. All right, let's go on to the next one. We'll have more practice on that. So if you don't get it just yet, there's a few more problems on this worksheet that have it like that. All right, number 3. This one has numbers. Don't get freaked out. It is the exact same principle the entire time. So in this one, I need a again, but I have a in the denominator of this fraction. So how do you get a or anything out of the denominator? By multiplying. So I'm going to multiply this side by a and this side by a. On my left side, my a's cancel out, which is what I wanted them to do. So -1. And I'm not going to multiply a into this parentheses because I want a to be by itself. So I'm just going to put it up front. and keep my parentheses in place. This will make sense in a moment. All right, so I have my equation written out. I need to now move everything else away from a. So I'm still trying to get a by itself. This side of the equation reads a is a times negative w plus 4v. A times the whole thing. Well, how do you undo multiplication? By dividing. You can actually divide this whole side by everything in those parentheses. Negative w plus 4v. And you can divide that by both sides because a is being multiplied by everything. And so your answer would literally be 1 over the parentheses, negative w plus 4v. And again, I have a variable, two variables actually, in the denominator. Now I can't easily solve for this one, so I'm just going to put that negative w plus 4v cannot equal 0. But whenever you only have one variable, you can solve for that. But I have two variables in this instance, so I can't solve for it. So be aware, there will be times when a is multiplied by a parentheses. And so it is possible, you are allowed to divide that whole thing away because a is being multiplied by the whole thing. All right, let's go on to the next one. Again, we still have numbers. Do not get weirded out. This time we're looking for x. X is right there. So I need to get the 3 away. So I'm going to add 3 to both sides. Now think back to when we first started solving equations. You can only combine like terms. This 3 is a normal 3. No variables attached. That has a variable and that has a variable. So there is no normal 3 that I can add this 3 to. So it's just going to tag on to the end. Like that. Okay, so we only combine like terms. There aren't any like terms, so they all just sit where they are. Last but not least, we need to get rid of this negative sign because we need a positive x. So I'm going to divide by a negative 1 because there's always a 1 right there. And then I'm going to divide this whole side by a negative 1. Which means I have x is equal to a negative 3n minus a 3p minus 3. Dividing by a negative 1 changes all the signs from the other side. And that's my answer. If you've noticed, we're only using the exact same principles of math that you would use if you had a normal equation, so numbers and such. And the only difference is you have more than one variable. All right, let's go. Here we go, last two. So in this one, I'm looking for x. Here's an odd thing. I have x in two different places. Now that's okay. It just requires an extra step. So I'm going to add 3x to both sides because I'm going to get all my x's on one side of the equation. So 3 is equal to xu plus 3x. All right. Now, do you see that we have x in both of these terms? We have two terms here, 1, 2, and x is in both terms. Think back to when we did distributive property. Remember, distributive property was multiplying x to each individual piece. Well, this time we're going to do it backwards. Okay, if you can, in math, if you can go forwards, you can also go backwards. Most of the time, if you go forwards, you can go backwards. So instead of putting x in, we are going to take x out. And I'm going to take x, I'm going to put it up front. And then I'm going to, in my parentheses, have whatever's left. So u goes right here, plus 3. So all I did is see that I had an x in both terms and pull it out of both terms and just stick it up front. Okay. Now I have a situation like that last problem where the variable is times a parentheses, is being multiplied by a parentheses. So now I can just divide by my parentheses from both sides, and I'm left with x is equal to 3 over u plus 3. And I have a variable in my denominator, so my last step is to solve for whatever that variable isn't. Because remember, the denominator cannot be 0. And in order for that to work, u cannot be a negative 3. All right. Last problem, we're going to do the distributing again. So we're going to do it, same principle. Over here, we're still solving for x. I have an x right here and an x right there. So first, I'm going to move my x's to the same side of the equation. So 3 is equal to xz plus x. Now I have two terms here, 1, 2. So when I pull my x out of each term, I'm going to put it up front. Let me change colors. I have x up front, and then parentheses, whatever is left. So my first term is going to be a z, but my second term is going to be a 1. Because remember, there's always a 1 right here. So when you pull out an x, the spot is still there. You started with 2 places, you have to still have 2 places in your parentheses. So my 1 is what gets left behind. Okay. And then likewise, I'm going to divide by the whole thing, the whole parentheses. Oops. And I'm left with x is equal to 3 over z plus 1. Solve for what the denominator can't be. And here is my final answer. And that is it for literal equations. All you're doing is solving for the variable that you're looking for and moving everything else away from it. So the 2 big things I want you to remember. Number 1, your denominator cannot be 0. So if ever you have a variable in your denominator, you have to add on to your answer what the denominator can't be. Now it's totally fine, let's just say, making up a question. So making something up right now. Let's say you ended up with x is equal to 1/4 a. Or let's rewrite this so it's a little easier. Let's say you ended up with a divided by 4. Okay, in this instance, there's a number in the denominator and it's by itself. Okay, there is no variable in this denominator. So there's no way this denominator can ever equal 0. So this would just be your answer in that case. Okay, the only time you have to announce what the denominator can't be is if you have a variable in your denominator. All right, so that's number 1. You cannot have 0, your denominator cannot be 0. Number 2, the distribution step down here. If ever you have a variable in 2 terms or in multiple terms, you can pull that variable up front and then just put what's left behind in parentheses. All right, let me know if you have any questions. We will also go over this before the test tomorrow. And have a good rest of your day.